Welcome to our FTP English version. Viewers, scientists are taking an important step towards understanding how the ocean captures and stores carbon. So, a new research from UC Santa Barbara and its collaborators suggests that the traditional explanations for how carbon dioxide is fixed in the dark, deep layers of the ocean may need to be revised. The team led by UCSB microbial oceanographer Alison Santoro and published in Nature Geoscience present findings that help resolve long-standing gaps in estimates of nitrogen availability and dissolved inorganic carbon fixation at depth. Something that we have been trying to get a better handle on is how much of the carbon in the ocean is getting fixed, Santoro said. The numbers work out now, which is great. And this project was supported by, in part of the National Science Foundation. Who is doing the fixing? Yeah, the ocean plays a critical role in controlling Earth's climate. It absorbs roughly one third of the carbon dioxide released into the atmosphere, acting as the planet's largest carbon sink and helping to moderate global temperature. Because we depend on this natural system, scientists aim to fully understand the intricate pathways that allow the ocean to store carbon. Yeah, we want to know how carbon moves around the deep ocean because in order for the ocean to impact the climate, carbon has to make it from the atmosphere to the deep ocean, Santaro said. Much of the ocean's inorganic carbon fixation is carried out by microscopic life. At the surface, phytoplankton take up inorganic carbon dioxide, including dissolved carbon dioxide gas, and function as autotrophs, creating their own food in a process similar to photosynthesis on land. Through this process, they turn carbon dioxide and water into organic compounds that salt sugar and oxygen. The prevailing idea has been that while most DIC fixations happen in the upper solid layer, thanks to photosynthetic phytoplankton, a significant amount of non-photosynthetic DIC fixation also occurs in the dark layers of the ocean. An assimilation dominated mainly by autotrophic archaea that evolved to oxidized ammonia, a nitrogen-containing compound for energy rather than sunlight. However, when tracking these carbon-fixing microbes' nitrogen energy budget through water column sampling, researchers soon found that the numbers were not matching up. There is a discrepancy between what people would have measured when they went out on a ship to measure carbon fixation and what was understood to be the energy sources for microbes, Santro said. We basically could not get the budget to work out for the organisms that are fixing carbon. They needed energy to do that, she explained, but there did not seem to be enough available nitrogen-based energy to go around in the deep ocean for the rates of carbon fixation being reported throughout the water column. Beyond this exclusive report, FTV English Delhi.